manager with 75 billion under management. When we're looking at SPAC candidates for our companies, we're looking for industry leaders that have the potential to double, triple, quadruple in size over the coming years, and something that's not related to my core businesses, which are really real estate. Having said that, there'll be a time, I'm sure, when 3D printing will hit the real estate industry in a big way. In the meantime, this company, Velo3D, is a leader. It's sort of the Tiffany's of 3D printing. And we were attracted to the company by the fact that it was already gross margin profitable, and it supplied industry-leading companies like SpaceX, who in due diligence said it was a mission-critical company for them. They help make the engines of SpaceX. And also by Benny Bueller, who's a world-renowned leader in the field. And the company has a moat supported by 48 patents in its processes. So with the capital that we're providing to them, we clearly see the future growth of this company as it expands its customer network, its sales efforts, its onboarding of the technology, and the addressable market is huge. You can define it any way you'd like, but it's a very big market which will grow exponentially. And then Velo, which is a relatively new player in the field, took almost 5 years to perfect their own engineering processes and their own technology, should steal share. So you can define the market as 12 billion, 25 billion, 120 billion. It's really concentric circles of demand. But this company is gross margin profitable because they are mission critical manufacturing capabilities for the companies and its customers that it serves. And they also have a SaaS model because they sell the machinery and they sign up a service equipment contract with these people, which they can then update and bring forward. So they're partnered with their customers in helping them do the most intricate procedures, which are mission critical and high value add, and thus they have pricing power to create the margins that they have. So we're super excited, and I hope you'll enjoy hearing from Benny Bueller, who's really the leader in the field. Thank you.
Thanks, Barry. Turning to slide 7. Bill, do you mind presenting yourself?
Sure. I'm Bill McComb. I'm the CFO of Velo3D. I was formerly the Chief Financial Officer of Maxar, the publicly traded space technology company. I was also CFO at HCO, a leader in nano coatings for electronics. And the first part of my career, I was a managing director in investment banking at Morgan Stanley and also at Bank of America Merrill Lynch.
Thank you, Bill. My name is Benny, and I'm a physicist. The first 10 years of my career, I spent in the technology unit of the Israeli intelligence. We worked on mission impossible parts of extremely high value for the national security. I got the National Security Award when I was 29. Later on, I moved to the United States, where I worked in applied materials and led development projects. And I later on moved to solar industry. And in the solar industry, I led the technology development in First Solar, where over my less than 5 years that I worked in the company, we almost doubled the efficiency of the solar modules in the company. I spent 2 years as an investor in Khosla Ventures, and that's where I stumbled upon this huge opportunity. Let's turn to slide 8. The company was founded in 2014. We have been at that for quite some time, and this is an extremely deep technology that it took us about 4.5 years to develop. And what we developed is an extremely differentiated technology that can unleash a very big market with its unique capabilities, creating a large blue ocean market space that we can take advantage of. We have strategic impact on our customers, and we are continuing to develop new products that are further expanding our technology advantage as well as our addressable market. Let's move to slide 9. Let's talk about additive manufacturing, metal additive manufacturing. There is a huge gap between the promise of metal additive manufacturing and the reality. The promise of metal additive manufacturing is really remarkable. You can take a very complex product, and this product could contain tens or sometimes even hundreds of parts, and you can consolidate that to a single assembly that would be manufactured as one part. This could result in much higher performance. The product could be lighter, more efficient, more reliable, and it can be produced at a much shorter lead time and at a significantly lower cost. The problem is that these parts that are coming from this exercise are actually very often not producible. What you can produce after a very long process of iteration and redesign is something that is significantly of lower performance, and it's extremely difficult to implement, requires a lot of knowledge, it takes a lot of time. What we have figured out is how to make that happen. Let's turn to slide 10. We have figured out how to do this. What we developed is a very differentiated technology that enables the production of the parts for which people turned to additive manufacturing to begin with. What we sell is a product, a full stack solution that includes software, hardware, and manufacturing process that we sell on the order of $1 million. It could be a little less, it could be more, but think of that as about $1 million piece with a very significant recurring revenue component. What we sell is a production solution. We are not in the business of selling services. We are not in the business of selling parts. We sell the full solution. It's a turnkey solution for our customers. By doing this, we unleash a very large market. This is the market of high-value production part, and we unleash a much faster adoption in this large market. And what we have developed is a very deep technology that is extremely hard to copy, and that is protected by a lot of patents that would make it very difficult for others to copy and to copy what we have done. Let's turn to slide 11. To give people an idea of what we are doing for our customers, let's look at SpaceX. SpaceX has been on a mission that is one of the most challenging and daring missions in human history, the colonization of another planet, the colonization of Mars. This vehicle that SpaceX has been building for that is the Starship. And the Starship is powered by the Raptor engines, which is an extremely sophisticated, extremely innovative engines. Velo3D technology has been critical for SpaceX and to solve the problems associated with the development and manufacturing of the Raptor engines. And I can say that we are helping to power the breakthrough that is the Super Heavy and Starship launch costs through our help to SpaceX on the Raptor engines. SpaceX has purchased their first machine less than 3 years ago, and within less than 3 years, they bought from us 22 systems and became an investor in the company. Let's look at slide 13 now. We are operating in the market that is the high-value metal additive manufacturing market. This market is already a large market. It's a $100 billion market, growing to $180 billion market. This is the market of parts where the vast majority of the cost of the part is the manufacturing process. It's the conversion of raw material to the finished good. You find those parts in aerospace, in energy, power generation, as well as in a number of industrial applications. The additive manufacturing portion of this market is not insignificant. It's already reaching $2 billion, and it's growing quite quickly. However, with the unique capabilities that Velo3D brings to the market, we would be able to accelerate the growth of this market in the next decade. And we believe that with our help, this market will reach $35 billion by the end of the decade, of which about $20 billion will be a segment of the market that is purely enabled by Velo3D, served by Velo3D, and we are the only ones that will be able to serve it. Think of that as blue ocean that we created, and we are the only ones that will be able to address. Turning to slide 14. So why high-value parts are so ideal for additive manufacturing disruption? If you look at high-value parts, you find them in complex products that have many internal parts and internal surfaces, internal features. Those are parts that are very difficult to produce, very difficult to machine, and those are parts with very long lead time and very difficult quality requirements. Additive manufacturing, in principle, allows significantly shorter lead times. It allows potential differentiation. You can get better products. But most importantly, because we are talking about parts that are expensive, where the alternative manufacturing technology is already quite expensive, additive manufacturing in many cases can be cost competitive with those parts today. There is a large opportunity already within this segment for additive manufacturing to be cost competitive without the need for a revolution in cost. What often is needed is a revolution in capability. That is the revolution that Velo3D is bringing to the market. Turning to slide 15. So what is this gap in capabilities? So when we look at the existing competitive scape in additive manufacturing, in metal additive manufacturing, the vast majority of the market of metal additive manufacturing is by one technology, is powered by one technology. This technology is called powder bed fusion, and the companies that are doing that are in this market for a long time. The first companies that are in this market that started working on that in the previous century. This technology is very established, very mature, and the capabilities of all those companies are very similar. They are selling very similar capabilities with very similar limitations. All these products suppliers that I kind of refer to as commodity additive manufacturing incumbents, they share two very fundamental limitations. The first one is that if you have a legacy part, you generally cannot reproduce it for additive manufacturing without redesign. You very often would have to redesign those parts because they contain features that make them non-friendly for additive manufacturing. You would need to use what's called DFAM, design for additive manufacturing, to make them manufacturable by additive. If you're trying to design a very high performance system where you're trying to design a new product from scratch, very often the optimal designs would not be manufacturable by additive manufacturing. You would need to start redesigning, compromising the performance in order to make this product manufacturable by additive manufacturing. Both those limitations are limitations that we are removing, allowing people to make the actual product that they want, the products that they need, whether these products are already existing products that they are trying to reduce their lead time, or whether they are trying to make new products with superior performance. In either case, we are enabling them to make the exact parts that they need, not the parts that the additive manufacturing industry for years, for decades, told them that they should be making. Turning to slide 17, we are solving big problems for big customers in big industries. We serve customers in the space, aviation and defense, energy, as well as other industrial applications. In all those markets, we are serving mission-critical applications, very often applications that are at the core of the products that these customers produce, the parts that are defining the performance of those products. And failure is not an option for us. I would like to talk about some specific examples. So let's turn to slide 18. Let's start with Honeywell Aerospace. So Honeywell Aerospace has a very significant problem. They have a very large portfolio of parts that they have been trying to move to additive manufacturing in order to solve their supply chain problems. They have spent a lot of time on that, and they have been successful in moving to additive manufacturing a very small portion of this portfolio. The vast majority of those parts are not friendly for additive manufacturing, but this does not prevent them from being manufacturable with Velo3D. Honeywell has been qualifying Velo3D as a manufacturing solution, and this qualification is planned to be complete in Q2 of 2021. Slide 19. This is an example of another supplier. This supplier is a supplier that sells flow control solutions for the energy and oil and gas industries. And they have thousands of parts that are consumed at low volume. So think of them as parts that are often consumed at less than 20 parts a year. But those parts have a very long lead time, sometimes 1 year and more. The result is that even though they are managing a very big inventory of those parts, very often there are parts that are missing, and this results in production disruptions to its customers. So this company has been working on creating a solution of spares on demand using additive manufacturing, but the problem that very many of those parts are not manufacturable by additive manufacturing. They have to be, by the commodity additive manufacturing, they have to be redesigned to be manufacturable. They are manufacturable with Velo3D, and the first parts of those are already in test in the field. This customer, as well as other customers in the energy space, in this opportunity of digital inventory, this spares on demand that is produced using additive manufacturing, they present a $500 million a year opportunity for Velo3D, providing the manufacturing solution that will produce the parts for those parts. Let's turn to slide 20. This is an example of a jet engine manufacturer that has a very different problem. They have been trying for a long time to consolidate an existing engine to one part. And the problem is that when you take this single engine and you convert it to one part by a simple consolidation, the resulting part is not manufacturable by commodity additive manufacturing. It has a lot of features preventing it from being manufacturable. So this company has been tweaking the design of this part, changing it, doing simulations, but the best they were able to accomplish is an engine that has more than 25% degradation in power compared to the original engine. This makes this engine not usable. This is not acceptable solution. Velo3D has been able to look at this engine, look at this assembly, and not require all these design compromises. We have no problem manufacturing the engine as is without having to make all these design compromises. And as such, we can produce this engine accomplishing the same power, but allowing less than half the manufacturing costs and more than 10 times reduction in the production time. With this customer, this represents more than $100 million a year opportunity for Velo3D. Until now, I talked about the value of what we are doing to our customers. I would like to spend some time talking about what it is that we are doing that is different than the incumbent commodity additive manufacturing suppliers. So to show that, I'd like to look at the part that you can see on the right. This part is the poster child of parts that you would want to use additive manufacturing for. This part has a lot of internal structures, making it not manufacturable by machining. It's very difficult to cast and even difficult to manufacture through machining or casting of individual parts and then welding them together. In either way, this is a difficult to manufacture part with that could be manufactured as an assembly, as a number of parts that would then be combined together with a high manufacturing cost. This is the perfect part to try to produce by additive manufacturing. The problem is when you try to produce this part by additive manufacturing, by the commodity additive manufacturing, what you see is what happens on the left. All the red material that you see on the left is support material that is added to this part in order for this part to be able to produce and not destroy itself while it's being produced. As this part is being produced, when you finish the production, now the part contains all this additional metal that is inside the part in all these internal cavities, in all these internal structures that are not accessible to the outside world. The problem now is that this part is really not usable as is because there is no good way to remove all this support material from it and no good way to finish it to the right surface and to the right qualities inside. So the only thing that you can do with this part by commodity additive manufacturing, once you finish it, is to take it carefully and put it in the garbage. There's no good way to actually finish it. What you can see on the right is how we produce this part. This part is produced with our support-free technology, such a way that there is not a single support inside the part, and the part, as is, all these internal cavities are already at their final performance as produced from the machine. And this part is an example of the type of capabilities we bring. And when we look at all the four previous examples, whether it's SpaceX, Honeywell, the Flow and Gas Company, the Flow Company for the energy and oil and gas industries, as well as the aerospace engine manufacturer, in all of those, it was about parts that their internals would require to have supports in places that are not accessible, and that the elimination of those supports by design would incur performance compromises, performance degradations. And with our technology, we can eliminate the need for supports, and we eliminate the need for this performance degradation. Let's go now to slide 23. The way we accomplish that is by bringing to market a full stack solution. This is a solution that includes software, the print preparation software that is called Flow, the family of our metal additive manufacturing printers that is called Sapphire, the quality control software that is called Assure, and our underlying manufacturing process. So Flow is prescribing the process, Sapphire is executing this process, and Assure is validating this process. These blue arrows that are the interfaces between Flow and Sapphire and between Sapphire and Assure are proprietary encrypted interfaces. This is all one environment, one solution, one turnkey product that allows the customers to start getting the product and immediately making parts without having to spend years developing processes and solving part-specific problems. All those part-specific problems are already solved by Velo3D. The crucial part that we are doing is that Flow is a very intelligent software that is doing extremely sophisticated computations where it is identifying all the unique features in the part that require unique manufacturing processes or manufacturing recipes. Flow applies those recipes to the part and creates a single manufacturing file that is going to produce them. Sapphire is then executes those recipes. And we had to invent a number of new system innovations in Sapphire to be able to execute those recipes, a number of places where Sapphire is deviating from the existing powder bed fusion architecture to execute those recipes. And Assure is validating those recipes, and it is extremely critical to validate those recipes because these recipes in many of the cases are extremely difficult to control. So we have to validate that the machine is always exactly calibrated exactly the way we set it up so that the result of the execution of this recipe will be successful. So we had to develop the full solution, the full 4-product solution in order to be able to execute those recipes. This statement that we are way ahead of competition is a statement that we hear from many of our customers. And frankly, we heard it also from some of our competitors. Slide 25. So we protected our technology with a deep IP moat that is intended to increase the risk and reduce the likelihood that someone would copy our solution. Our IP is protected by extensive number of patents that are protecting the systems, the methods, and in some cases, the composition of matter that we are producing. And those patents can be used to prevent people from copying our systems and selling those systems, from using those copied systems, and from trading in the parts produced by those systems. Turning to slide 27, I'd like to talk about our commercial evolution. What you can see here is the growth of our revenue. We launched our product in Q4 of 2018, and then in 2019 to 2021, our focus was on seeding the market, expanding the customer base, and diversifying the applications. This is 100% about technology adoption, about learning the value proposition, and figuring out how to sell this product. Starting 2022, we are in the scale-up phase in the broad commercialization, is replicating what we have learned how to do with the first few customers and with the applications where we learned to provide value. As an example of that, of the $89 million that we planned for 2022, more than $50 million are already accounted for in the form of bookings, pre-orders, or recurring revenue from existing systems that are already sold. Let's move to slide 28. We have 4 drivers that we strategically use to direct our growth. The first is the blue ocean principle. And the idea here is we are only focusing on applications where we are the only one that we can solve the problem of the customer uniquely. We can provide unique value, and as such, we can create an opportunity and nurture an opportunity that we are the only ones that can serve. The second principle is the principle of land and expand. We are only focusing on manufacturing customers that, in our vision, would need many systems in the years to come. And as such, we are going to get more and more revenue from those customers as they will expand their relationship with us. The third principle is the introduction of new products that expand our competitive advantage and expand our addressable market. And finally, new customers are extremely critical for our land and expand model. Even though the vast majority of our revenue every year is coming from customers that we acquired earlier, new customers and expansion of the customer base is critical for future revenue. So expanding this customer base is important, and expanding geographies and expanding partnerships and doubling down the sales force and our marketing team is critical to drive this growth. I will now hand it to Bill to take it through the details of this strategy. Bill, take it from here.
Thanks, Benny. Turning to slide 29, the first element of our strategy is to focus on the market we call the blue ocean. These are those customers who want the advantage of additive manufacturing, but for whom the complexity or geometry or other internal features of their parts is such that only Velo3D technology is capable of making those parts. We explicitly avoid competing for applications in the red ocean, which are those applications that can be served by multiple existing 3D printing players. In this way, we're building a market where we alone can operate. We believe this market is very large and can reach $20 billion in sales by the end of the decade. Turning to slide 30, the second part of our strategy is to land and expand at every customer. We sell only to production customers and not to prototypers or research labs or the like. Production customers, as a rule, need multiple systems. Their demand grows over time from an initial system that they use to qualify the technology to multiple systems as they scale up their manufacturing activities and expand their use of our technology for more and more parts. You can see this pattern demonstrated with these 5 of our recent customers shown on the chart, and how in just 2 years they bought more and more systems. On average, we would expect a single production customer will buy 9 systems over the first 5 years. Turning to slide 31, the third part of our strategy is to expand our technology lead and our addressable market through new products. Our next new product is the Sapphire XC, which will ship in late 2021. It's a huge step function increase in part size capability and productivity. It can make parts that are 400% larger than the existing Sapphire system, and at a production cost for our customers that's 65 to 80% lower than existing systems, thus making our additive manufacturing technology competitive against legacy metal manufacturing techniques in a much wider range of applications, and thereby expanding our market. This product has seen very strong customer demand. We already have orders and reservations of $47.5 million for the product to date. Turning to slide 32, the fourth part of our strategy is to accelerate customer acquisition by entering new markets with distribution partnerships and ramping up our direct sales and marketing activities. Initially, in 2018 and 2019, we focused just on the U.S. market. Last year, we entered the Asia-Pacific market, and more recently, at the end of last year, early this year, we entered the European market by establishing key distributor relationships in those regions. As we get established in those markets, we'll see the same acceleration we saw in the U.S., but with a 1 to 2 year lag reflecting the later start in those markets. So these regions are going to add new legs of growth to our top line as we penetrate them. We're seeing that already in Asia Pacific, where we've had several system sales already, and we're beginning to build a pipeline of opportunities in the European market. Let me now turn to the financials. Let's first look at slide 34. We have 2 transaction models, a straight sale and a recurring revenue model, which has a lower upfront payment and annual recurring payments thereafter based on utilization. We expect that the recurring revenue model will likely generate higher total payments over the life of the machine. However, many customers prefer it and are more willing to buy with a lower upfront fee, so it expands our universe of potential available customers and therefore our market to have both models. In 2020, 20% of our unit sales were recurring revenue deals. This year, we expect that to be 40% plus and to exceed 50% over time. So the recurring revenue stream generated by those unit sales will be an increasing portion of total revenue going forward. Turning to slide 35, this slide shows the expected lifetime cash flows from the 2 models. On the left is the pure sale, which has a $1.75 million upfront payment and $120,000 per year service contract. And then on the right, and these models are for the Sapphire, the existing Sapphire system. The recurring revenue model has a $750,000 upfront payment, $60,000 per year for service contract, and $50 per hour of system utilization going forward. The ARR model, as you can see, is expected to generate 35% higher revenue and 70% higher gross profit based on an assumption of 70% utilization of available hours over a 7-year time horizon. Turning now to slide 36, as you can see, Velo operates a very asset-light business model with very low capital intensity. Our manufacturing operations are limited only to final assembly and test. We source all our components and sub-assemblies from vendors. So our manufacturing operations are easily scalable with limited investment. And over the next 5 years, we would expect the CapEx would be slightly less than 3% of revenue. Turning to slide 37, we have very good visibility into 2021 and 2022 revenues. We have visibility today on a total of $48 million, or just over 50% of our 2022 revenue target. As shown on the chart, this is comprised of $6 million of recurring and service revenue, $15.8 million of firm orders for the Sapphire XC, and $26.4 million of pre-orders for the Sapphire XC. So we need to book $14.3 million above our 2021 revenues to reach our 2022 target. On slide 38, I'd like to review our financial model for the next 5 years. As you can see, we expect to grow very rapidly and reach just under $1 billion of revenue in a 5-year time horizon. The big jump is in percentage terms is in 2022, whereas I described above, we already have visibility on 50% plus of that revenue. Our highly differentiated product is reflected in high gross margins, which even at our current limited scale are at 34% in 2020. Our gross margins will increase as we scale up the business, and we expect to reach 52% by 2026. Operating expenses grow significantly, and this increase is driven by a very significant expansion in our sales, marketing, customer support, and engineering activities. We expect to reach break-even EBITDA in 2023, and by 2026, we expect our EBITDA margins to reach 34% as we leverage our high gross margin business model. And with that, I'd like to turn it back to Benny.
Thank you, Bill. Turning to slide 40 now, I will discuss the impressive team that we built in Velo. This is the team that built Velo itself. Alex and Greg are the technology and engineering leadership team that built the product, and they are part of the core team that built this product. Zach, as the leader of our sales, represents both strong sales acumen as well as strong technical capability. And Bill, as a strong public company CFO, positions us to a very solid decision-making and organizational processes as a public company. On slide 41, you can see the impressive group of world-class investors and board members supporting our visions. Our chairman, Carl Bass, was the CEO of Autodesk, and he's been with the company for a long time. Stefan Kraus will be our independent board member, as well as a mentor to me. He is also the chair of our audit committee. He was ex-CFO of BMW, as well as chairman of Rolls-Royce and executive board member of Deutsche Bank. He was a CEO and founder of Canoe. We have top-tier financial investors that were extremely supportive of us throughout the years. Bessemer Venture Partners, Khosla Ventures, Playground, and Piva. And we have two important strategic investors, SpaceX and Lam, that are also customers. With that, I would like to turn it over to Barry for a few closing remarks. Barry?
So this is Barry Sternlicht again. I hope you enjoyed hearing from Benny and learning about Velo3D. As I said, we think this company is a superior player in its field and will be the leader in its field with the best technology, the best moat, and a built-in roster of growth, where the majority of its 2022 sales has already been contracted. So as we look out in the valuation metric, there is another 3D printing company. It's a different industry, a different business, but we think this is a very attractive company, and it should be a future leader and kind of a moonshot, which makes sense for the fact that they supply people like SpaceX. So thanks for being with us, and we hope you'll take the time to learn more about Velo3D. Thank you.